All right, welcome to the latest edition of the Noyo Center Science Series. We appreciate you all joining us on an afternoon, windy afternoon here in Fort Bragg. It's great to see so many people come out. It really proves what an important issue this kelp recovery is for all of us. I want to take a moment to encourage you all to, we have a suggested donation of $10 for these talks. You can do that or not, but we encourage you to support us or any of your local nonprofits right now. It's been a tough year. I'm sure you all know that. So any inclination to give to your nonprofits, please follow through with that. We do have a membership drive going on right now, sustaining supporter drive. So if you're inclined to support us with a little bit each month, we appreciate that really. Okay, so let me get us started today. We have a lot to cover, so I want to introduce you to our speakers. It's really exciting to have what is now turned into a little panel of speakers, and everybody has sort of changed positions. So I'm going to just take a minute to introduce folks, but they'll do some more of this when it's their turn to speak. But before I get into that, let's just go over some logistics again. Let me just emphasize it'd be great if you could mute yourself, especially during the talk. If you want to ask questions, you can put it in the chat bar. If it's an appropriate time to break in, I will break in and ask the question for you. At the end of the talk, we can have more time where you can ask questions directly or put them in the chat, and we can have more of a free dialogue at that point. I don't need to point out where the bathrooms are. You probably know that. So we'll just get started. Okay, so let me introduce first Tristan Mckee. You probably know her from our partnership with Reef Check. This past year, she's been the regional manager for Reef Check here in the North Coast, but she's recently taken a new position at the Nature Conservancy as the project director. So I'm excited to work with her and to hear what they have planned. Stepping in at Reef Check for Tristan is our Ian and Morgan. So Ian Murphy Canella and Ian Norton, if you probably recognize our divers here at the Noyo Center, they started working with Reef Check this last year when Reef Check took over for the Noyo Center in organizing the commercial diver removal of urchin. So Ian and Morgan's they've been doing a lot of work on that front with Reef Check. And then we have Kristen Elsmore, who's doing her PhD work at UC Davis, who was also here at our seaweed symposium. Remember that. We're happy to see her join us again. Such a great panel of people, and we've got a lot to talk about. So we're going to dive right into kelp recovery on the North Coast, and I'm going to hand it to Tristan first.
Great. Can you hear me okay?
All good.
All right. Hi, everyone. Wow, this is quite a turnout. I'm super excited to be talking with all of you about this today. Let me just get this ready. Okay, can you see my screen? Can I get like an okay or a thumbs up from someone? Great.
Yeah, you're good, Kristen. Good.
Thank you. Okay, so hi, everyone. Wow, there are a lot of folks on this call, and I'm so excited to share this information with all of you. And truly, thank you, Noyo Center, for hosting. I think these seminar and community talks are just epic to have, especially right now. And this is like the perfect demographic to share this news with. So thank you, Sheila and Noyo Center. So today, Morgan, Ian, Kristen, and I are going to give a project update on the kelp forest restoration project. And this is a project that's been on the ground for a little while. And so we'd like to just show you what we found so far. So as an overview, I'll give a welcome, personal updates. I will also give a timeline overview of how this project's unfolded over the last few months. We'll then just dive right into data and get into the stuff that I know you're here for, which is what did the system look like before we started removals? How did the removals go? What did it look like after removals a few months later? And then we'll go over some of our Dockside landings data, and then look at some really cool wave graphs that Kristen Elsmore has been putting together. We'll then do a summary and then talk about what's in plan for 2021. And then we'll take questions. All right. So my name is Tristan Mckee. I was the former North Coast Regional Manager and Restoration Program Manager for Reef Check. I'd like to also introduce Morgan Murphy-Canella and Ian Norton, who are stepping in to these positions and are going to take over this project full on. And I'm so happy that they are, because they are incredible human beings. I'm so excited to see where they take this. And then we also have Chris and Elsmore. So all four of us will be speaking on different aspects of this project. So before we jump in, I'd like to just give a quick little overview of some of the work that the Nature Conservancy, the group that I'm working with, is going to be doing here in the North Coast. So I'm the new Kelp Project Director, which is a new position for California and the Oceans Program in general. And the cool part is I'm still based here in Fort Bragg. And so the whole idea of this position is to accelerate the protection and restoration of kelp forests in this area by leveraging innovative tools and approaches to restoration. And so we're acting local and we're thinking global. So one of the projects that we're working on, I saw Grant Downey on this call, is this purple urchin trapping work, which is really thinking about, there are so many urchins out there, divers can go out and remove urchin, but what would it look like if we started trapping urchin? So that's in the works right now. The second is an experimental bull kelp farm out of Humboldt Bay, which is the first experimental bull kelp farm in California, at least. And that's basically looking at, can we actually grow baby kelps in the North Coast? The next is looking at drone imagery of kelp beds, which for all of you up here know how much kelp we've lost. Drone imagery can tell us a little bit about where remnant kelp patches remain. And so this is a really cool tool that we're now exploring, and this data is now in peer review and should be published here probably in the next few months. This is another pretty exciting one. I mean, not exciting for the sunflower star, but for the listing, which is that they are now listed as critically endangered on the ICUN red list. So this puts them in this category of, hey, we acknowledge you're super important for the system. We should probably start thinking about ways of mitigating that loss and thinking about ways to restore them. Next is marketplace exploration. And the last one that I'm really excited about is Global Kelp Restoration Guidebook. And this is basically pulling together what folks in other communities all over the world have been doing to mitigate kelp loss. How did their community respond? What species were they working with? And the really exciting part is that this study that we're going to tell you about today is one of the case studies that's being highlighted in that Global Restoration Guidebook. And so that's a little bit about it. I'm happy to speak with any of you about this in greater detail at some point, but for now, I want to get in this, which is the Reef Check Kelp Forest Restoration Project. All right, let's get in it. So, timeline. There's this thing called COVID, and it happened last year, and it delayed a bunch of things in a lot of our lives. And so this project was actually funded about exactly a year ago tomorrow, actually, but it was delayed by COVID until May 2020. So that was the official starting date. We hired 2 restoration technicians, Ian and Morgan, and we started coordinating logistics. June was the first thing that we did was map the target area. What area did we want to actually restore? And so we went out to Noyo and we started designing this target area and the removal logistics. By July, we had this temporary cable installed that was going to be used as this navigational area, which we'll talk about later. How do we know where to survey and where do the fishermen know where to go? And we conducted our pre-removal surveys, logistics, boat prep. By August, we were going. And so this was the start of urchin control. So at this time, this is when we started physically removing urchin out of Noyo Bay. In September, we continued that urchin control in the shallow areas and the cell areas of the site. And we continued dockside work and quality control surveys. October, same thing, kept going. November, it started getting pretty messy out there. So we wrapped up our efforts We packaged our data. We pulled out Kristen Elsmore's wave ADCPs, the instruments, and it was the last urchin cull. So two key time points were July, which was when we did our pre-surveys before we touched anything in the reef, and October, which was a few months later when we did our after surveys or our fall surveys. And December, package data and maintenance. Ian.
Okay, so the question here was, can this be done? And so basically we were trying to figure out what it took monetarily and logistically to reduce the urchin densities on the resto site below a theoretical threshold of 2 urchin per meter squared, and if the kelp would regrow. So the 2 urchin per meter square threshold is just a number that's widely accepted to be a density where kelp can reestablish itself. So this first picture here on the left is pretty much indicative of an urchin barren. 1 meter squared is basically a box that is 1 meter on each side, and the number of individuals on the inside of that box is the density. So the figure there on the left is basically what you would find in a barren, and with pressures that great, it's really difficult for kelp to establish itself, if at all. So the next figure you're going to see on the right here is the density that we're trying to get to in this restoration site. So that is the big question, and we're trying to get it down to 2 urchin per meter squared or less. So that's important because, as we all know, the kelp forests provide a great habitat for an amazing variety of aquatic organisms, all the way down from plankton, moving on up the trophic levels to the fish that we see out there, the seals, all the way to the very top where you have the apex predators like sharks and humans. And in addition to this habitat, the kelp forest also provides plenty of numerous recreational, commercial, and economic opportunities for the coastal community here in Fort Bragg.
So now we are going to dive into the data. We're going to look at some of the numbers. So the first thing we did before we removed any urchin is Tristan, Ian, and I went out to survey the restoration site. So pre-removal monitoring. We went out, we conducted surveys to see what it looked like out there and determine the densities of certain organisms. So in July 2020, we went out for these surveys, and there's a lot going on this page, so I'm just going to kind of explain it piece by piece. So we surveyed 2 sites. We surveyed Noyo North, which is our restoration site, and then we surveyed Noyo South, which is our control site. So we have restoration in that orange-brown color, and then we have our control site in the teal. And then we have this graph, and on the y-axis, we have density, and that's the number of organisms per meter squared. And on the x-axis, we have all these organisms that we counted: red abalone, purple urchin, red urchin, bull kelp, laminaria, and pterogophora. So we all know bull kelp is the canopy-forming kelp species, and then the laminaria and the pterogophora, those are the understory kelp species. So if you want to relate this to a redwood forest, the bull kelp are redwoods, and the laminaria and the pterogophora are the ferns of the forest. So they're the lower kelps. And this purple line we have is the theoretical threshold 2 urchin per meter squared. So we went and we counted all the things, and we found that there were similar densities of purple urchin in the restoration and the control site. There was a little bit of a difference, a little bit more in the control, but both far exceeded that 2 urchin per meter squared threshold. We counted red urchin. They were very similar in densities in both the restoration and control site, and they were both below that 2 urchin per meter squared thresholds. We counted a few red abalone, but nothing significant to show up on this graph, and we essentially saw no kelp at all.
All right. Thank you, Morgan and Ian. That was great. So next are the removals. So as they mentioned, that was the baseline that we were kind of working with there. So lots of urchin. So like I said, we mapped our target restoration area, and this is Noyo Bay. So this red area was what we deemed as the area that needed to really get worked on. Over here, it was actually a bit more patchy and kelpy and mixed. And so we were like, we really need to target this area. This line right here in green is this map, this trail that we created where every 10 meters there were little markers. And that's how the fishermen and we knew where to go, and that we were systematically clearing out this restoration area.
Okay, so after our pre-removal surveys, we sent the commercial urchin divers to go clear out that site that Tristan just explained. And so this graph shows the amount of urchin removed in pounds by date. So the y-axis there, yes, pound, x-axis is date. And from July 25th to November 1st, we the commercial urchin divers pulled out 26,535 pounds, which is really quite amazing. There were 27 on-water days and 49 individual vessel days. So of those 27 days, there were multiple days where we had multiple boats go out and remove. So if you can see on 9/13, on September 13th, there's a lot of pounds that came out of the site, and we had 4 boats out that day collecting. So that was a huge day. Next. So this is our site that Tristan explained, but what we ended up doing is we split it into 2 sections, right? So we have the deeps and the shallows. The deeps, or the cells, is where the divers would systematically remove urchin in these swim lanes in very specific locations. And then the shallows is an area where they would drop anchor, they would take a GPS location of where they were, and they would gather urchin kind of opportunistically. So it's kind of 2 different areas of the cell of the restoration site. And so if we take that original graph that I showed you of pounds removed, and we overlay area, next slide, and we overlay area, you see that in the beginning of the project from about, let's see, August or July 25th to August 26th, most of the removals were concentrated into the deeps or into the cells. And then from September 1st to November 1st, their efforts were mostly concentrated in the shallows.
So all of this is really, really interesting. And this is exactly why we wanted to partition the site we did, was because we had an idea that there were more urchin in the shallows, which is a behavioral component that they do because most of the kelp aggregates into those shallow areas. And just behaviorally, we knew that they were there. And so what was really interesting about this is when you think about the total site, as Morgan said, you're thinking about 26,000 pounds. But in the deeps, if you looked at what we collected there, we're looking at, 7, almost 8,000 pounds in that deep area. But then you're like, wow, we collected so much more in the shallows. But, an obvious question is, did you spend more time in the shallows? Like, what's that about? So if you dig a little bit deeper into this graphic about pounds pooled and then the number of vessel days, which is indicative of, the amount of effort that we spent in those areas, now you have this almost inverse relationship where we ended up spending almost maybe a couple more days in the deeps, but pretty similar number of days in the deeps and shallows. But when you look at the poundage pooled, it's exceptionally more in the shallows. And so the results of that is that in the deep areas, there was more area to cover. Divers were spending, so we had that benthic cable, we gave them 100-meter tapes and we're like, go north or go south. And 2 diver pairs would swim next to each other. and systematically clear these urchin, right? And so they were spending time searching for urchin versus after that 100-meter mark ended, that's when we started going into the shallows. And what the divers would do there is get a GPS point, drop down, and just spend all their time in one concentrated area, just clearing urchin because of how dense it was. And so I think like the key note of this though is, do you need to spend time in deeps and shallows, or could you just go to the shallows? And what we know about urchin is if you don't clear all of them out of a site fully, they will move into those spaces again. And so being thorough was perhaps worth the cost, but we need to look at our data to be certain about that.
Hey, Tristan, can I break in with a couple of questions before you move
Sure.
on to the next section?
Yeah, that sounds great.
So Keenan was asking where the 2 urchin per square meter came from.
Yeah, thank you, Keenan. It's this theoretical number that folks in other parts of the world were using. And it's like, it's not a certain number. You need to get your numbers less than 2 urchin per square meter, but that's the target number that you should shoot for to reverse shift a system back from urchin barren to kelp forest. So what's kind of interesting is if you think about a regular kelp forest, it could withstand way more than 2 urchin per square meter if it's in the kelp forest state. But once it's transitioned into the urchin barren, if you want to push it back into a kelp forest, you have to get that number to near 0. So you need to get as low as you can. And so that 2 urchin has been demonstrated, I think, in New Zealand and Japan were the 2, and potentially Norway also, where they found that number to be like just about there.
Okay, and Peter's asking, can you give us a reference size of the study area?
10 acres.
10 acres,
Thanks
great.
for asking.
And Oren wants to know, what is the depth between the shallow and the deep areas? What's the border depth? What's basically what's the difference?
Divers standing up, they could literally walk out of the water to 45 feet.
Okay.
And so it goes, there's that cliff area. And so at the cliff, you're out of, you could just walk out of the water. And then it gets deeper as you move south, and there's this sand channel. And I didn't mention that, but we chose this restoration site predominantly because it had choke points. So on the north, there was a cliff. On the east, there was all that kelp. On the south, there was a sand channel. And so the only spot urchin could come into that site was from the west side.
Interesting. So Robert wants to know if there were behavioral differences in collecting by divers in the deep versus shallow. For example, better viz in the shallow, making it easier.
I kind of want Grant to answer this, but maybe he can jump in at the end and give like a fisherman's experience to this. But, it actually got super soupy over towards the furthest west part of the site. So the cable that we have underwater, the temporary one, goes from 0 to 15, spaced every 10 meters. So 150 meters long. For those of you who have dove Hopkins Marine Station or Big Creek, it's like that cable basically. And so you have this linear line underwater sort of. And as you get further, 0 is to the east side by the closer to shore, and then offshore is 15. As you get to like number, what Morgan Ian, like 11, 12, it starts getting like, yeah. That's like, we don't like going there. It's pretty gross over there.
All right, we're gonna let you keep going now.
Okay, thanks for the questions. Sheila, one more thing. I just got a ping from a couple folks that were trying to get in, but it was capped at 100 people.
I know, I got that same message. I'm surprised
Okay.
by that because we shouldn't have a cap. We upgraded.
Yeah.
So all I can say is we will put this for everybody listening. This will go up on our YouTube channel, and we'll have a link to it on our website as well. So for those people who know people who can't get in, we'll just make sure they see it after the fact.
Awesome. Thank you, Sheila.
Yeah.
Okay, moving on. So now, this is the crux. We're there right now, which is the post-removal monitoring. So what happened between, July I think it was July 30th. It was my birthday when we did one of the restoration sites. From that pre-monitoring data to October, I think it was 17th, like what happened in that time frame. So Morgan did a really great job explaining this graph earlier. Same on the x-axis, we have the species, y-axis, density. And remember, a meter square is literally like 1 meter. Like, think about the middle of your body to the tip of your fingers, basically, out and then forward. So that's the area that we're talking about there. So that same line. And so restoration yellow, control teal. So what did it look like? Purple urchin restoration site is here, below that too, and then the control site at far exceeding, very similar to what it was previously. And we'll get into this a little bit deeper. Red urchin, same thing. We see a slight increase, a little bit more urchin in the control site, red. So overall, slightly more urchin in both sites. But I think the real key take home of this slide in particular is the reason why you have a restoration, like an area you're working, and a control site is, you know, that the control site is arguably not manipulated by us. So we weren't going in and removing anything from there. But what this is telling us is if we saw this number significantly decline down here or somewhere lower than, you know, it was by July, that would have told us that some kind of environmental variable could have reduced urchin densities, like a storm or a disease may have come in. And so our ability to detect that this was human induced would have been greatly reduced. And so in this circumstance, we can say that the fact that we're seeing less purple urchin in the restoration site was because we did that, humans did that. It wasn't some disease that came through and removed them. So now let's forget about the control, because we did what we needed to do with the control just now. So now we're focusing on Noyo North, the restoration site only. So now I want to show you what the site looked like in July and what it looked like in October. So pre and post clearings, same X and Y axis. So this is another key feature, which is purple urchin between July and October were reduced. And by October, it was in fact below that theoretical threshold. And we'll get in this a bit more, but same for red urchin. We saw a decline. So, and the other kicker is that we did not see any bull kelp, or we saw 1 or 2 individuals of bull kelp show up, but they're so small that you're not seeing it. And we'll talk a little bit more about the algae response, but for the sake of this, we did not see any adult kelps showing up at the site in these 3 months, which we're not incredibly surprised about. So now let's zoom in, same graph as before, but urchins at restoration site. This is kind of fun. So let's look at July again. This is what I just showed you. We're looking at purple urchin, red urchin. And now if you add those 2 urchin together, we're thinking, let's see what 2 herbivores together look like, right? They're both urchin. They both have the ability to eat and graze. What does it look like to their density when you add them together? So that's what you're seeing right here. So now let's look at October and stack that on top. So 40% decline between July and October for purple urchin densities, which is super fun. Red urchin, slight decline. And this could have been because there was about 1,000 pounds that we know of that the commercial guys actually went in and removed harvestable red urchin, which was something that we recommended, which was go in and remove the legal sized urchin if you can. We'll talk about that in a minute. But what I want to show you now is probably the crazy thing. So by October, even though purple urchin and red urchin were below that critical threshold of 2, when you add them together, that exceeds that theoretical number we were trying to hit. And so what that ultimately means for us is that that grazing pressure, that ability for kelp to be nommed, like it had the potential, and it probably did have the potential. And so what that, like, I think what's also interesting is thinking about the size of urchin that were left over. So like who was left over in the site? And so this is looking at underwater data that we collected of the size of urchin and the number of urchin. So we're looking at purples here. So in July, you're looking at this distribution here where most of the urchin were around 5 to 6 centimeters in size, right? But then in October, that graphic shifted to the left, right? So it's shifting this way into a smaller category around 4, like the average being about 4 centimeters. So what that could mean is that maybe smaller urchin were remaining in October because fishermen were saying like, I'm going out and I'm clearing these shallow areas and these tiny ones are showing up. And so it could have been very likely that after you remove the large individuals, the little babies come out and just do their thing. So another thing I just want to point out is it may look like there are more urchin in October. That's just because we measured more urchin. It's not because there were more urchin. Okay. Lots of graphs. We're almost out of here, but there's a kicker point at the end, I promise. So now we're looking at red urchin. So thinking about these individuals that are targeted prized fishery species for a lot of the commercial divers that are assisting with this project right now. And so here, same graph, we have July and October. July, we see most of the distribution here around 8. And again, same thing, this distribution by October shifts into a smaller category to the left and slightly, right? And so you're seeing less red urchin, or sorry, you're seeing smaller red urchin in October as opposed to July. And mind you that the commercial harvest size for urchin is 3.5 inches or 8.89 centimeters, which when you collect data, that would go to 8, right? So that would be an 8 category. So when we asked fishermen to go out and physically take out the harvestable ones, they did. But here's the kicker, is that most of the urchin that we needed to be removed were actually of non-legal size class. And so all the legal ones, they did a really good job of taking out, but look who's left over, the ones that we can't touch, because that is not a species that we are targeting for this restoration project. The project was to target purple urchin, not necessarily red urchin. And so we knew that going in though, that this was going to be an issue. And so what we want to do was build the case or demonstrate, like, do we actually need to remove red urchin or can we just leave them as is? And so pair together that graphic I showed you of purple plus red urchin and this graphic and thinking about who is left of those red urchin, you're in a situation where those who are left there have a really strong ability to graze, and we can't necessarily touch them at this moment. So, Ian?
Yeah, thanks. So back to that original question of can it be done? And the answer is yes. The densities of the purple urchin were able to be reduced down below our magic theoretical threshold of 2 urchin per meter squared, which was totally awesome and due to just the incredible hard work and diligence of all the commercial urchin divers that were working with us on this project. But additionally, like the graphs that Tristan was just showing, when you add in the grazing pressure of the other herbivore out there, the red urchin, it actually bumps that density up above our target threshold of 2 urchin per meter squared, which may negatively affect the kelp's ability to reestablish itself. So perhaps there might be too many mouths to feed on the 10-acre restoration site at this moment. But here are several pictures of the restoration site after purple urchin removals have been underway for some months. So once all the urchin were gathered, they're brought back into Noyle Harbor, where they're landed at the processing facilities. And we had 37 individual vessels that were sampled across 20 days. And 13 of those 20 days we had volunteers, which was phenomenal. I mean, we couldn't have done it without them. They were a huge help, and we always enjoyed seeing them there. Next slide, please. So we analyzed with the volunteers a total of 6,078 urchin. I could have sworn it was more than that, but so basically what we were doing was taking a subsample of the total catch that was landed, and we were weighing them and measuring their tests, the diameter of the test in millimeters, and then a portion of those were also dissected. And so basically we were breaking open the urchin and we were looking at two things: their stomach content and their gonad weight. So first we would pop them open and see what exactly they'd been eating. If they'd been eating brown algae, green algae, red algae. Often there's not much to eat in a barren, so sometimes there would just be rocks and sand or nothing at all. And then we would also scoop out their gonad and weigh that to get a gonad indexed. And basically what we were doing there is just seeing if there was a relationship between their stomach contents and their reproductive capacity.
And I think there was actually a question about this in the chat, but so this is showing not all of, a subsample of the urchins that Ian just mentioned that everyone measured. And they are broken out by the shallow and the deep. So this isn't showing how many were caught in those two respective areas, but this is showing kind of what the size range was in those two spots. And kind of some key things to point out here. So on the y-axis, we have the number of urchins. That's not the total number of urchins collected. That's just the number of urchins that were measured. And then on the y-axis, or sorry, on the x-axis along the bottom, we have the different sizes of the urchins. And kind of the area of where the humps are kind of at their peak is where most of the urchins are at that size. So you can see here that most urchins in both the shallow and the deep region were around 25 to 50 millimeters. And these numbers match the monitoring surveys that you guys saw the data for earlier, which is always nice when that aligns well. Another thing I wanted to point out here is you see a vertical line, this purple dashed vertical line that says sexual maturity. All of the urchins that you see on the right-hand side of that, those are capable of reproducing if the conditions are right. So as you saw from the photos of the urchin of this site, there's not a lot of food there for them to eat, but if they were given enough food to be able to produce and put into their gonad production, they could theoretically be reproducing and providing more urchins for our already very barren-stricken coastline. So you can see that we really pulled out, we as in the harvesters, the urchin fishermen, pulled a lot of important urchins out of this site.
So yeah, once again, got to give a huge shout out to Susan, Ed, and all the other volunteers. We listed a bunch of them here, and if your name is not on there, we thank you so much. We could not have done it without you. This picture on the left, I would just like to point out, is kind of just an up close shot of what's inside an urchin. And yeah, it would have definitely been eating some brown algae. And there's some pictures of its gonad down there on the bottom of the picture. But aside from that, like, there's surprisingly not much in an urchin besides water and some viscera. But yeah, next slide, please. So this is a perfect time to just talk about some Dockside volunteer opportunities. If you are in the area or not, and you're coming into the area and you would like to get involved, it's actually a lot of fun. We're working on a private dock. It's in the middle of summer. We're out there under a canopy. There's plenty of urchin to go around. And it's just a great community event, and it's a great way to get involved with this project that's going on right here in our backyard, basically. So if you're interested, please email Susan Piercy. Her email address is there. And I would appreciate it if you could CC me as well. And we will definitely let you know when there will be opportunities to dissect and analyze some urchin.
Thank you. That was great. And so now we're kind of at the end of showing some of the data. And I think it's kind of fun sometimes to talk about some of the little things that happen that were going on during a time of such confusion over summer and with COVID and everything going on. I don't know about the other three speakers on here, but I had an awesome summer. I had such a great time getting to dive, and what bummed me out was that the volunteers from Reef Check couldn't be there to do it with us. But along the same vein, we were just all trying to be safe. So hopefully this summer, as Ian mentioned, will yield a lot more opportunities, and feel free to reach out to the Reef Check crew to get involved and super COVID safe. So now we're jumping into just anecdotes and more tangential science.
So this is Kristen again. So in addition to helping with the urchin collections and measuring, I'm working on this project that's funded by the California Sea Grant and the Ocean Protection Council, that's geared towards working closely with Reef Check and the Restoration Project to fill in some of the gaps, the unknowns about bull kelp, and particularly bull kelp in the North Coast. And so what you can see here, these are some marine instruments, some oceanographic instruments that measure waves and current speeds. And next slide, please. And so we put these out and in the restoration site, just inside, and then outside, kind of on the edge. So where where we think the kelp will eventually grow in. And so here's a little schematic of the sensors set up inside and outside of the restoration site. And the goal here is to kind of get two pieces of information. One being, basically, we don't really know what the wave conditions and current speeds are where bull kelp needs to grow and release its babies, its spores. And that information is going to help us learn and predict kind of how far those babies will travel up and along the coast, which will help us decide how far apart these restoration sites maybe can be, so they can kind of feed into each other. And then another piece is we're gonna hopefully put these instruments back out once the kelp, again, hopefully grows in at this site, so that we can see how the kelp itself is modifying the waves and the currents. So giant kelp is known for really slowing down the flow. And so we don't really know to what degree Myriocystis, the bull kelp, does this. So we're hoping to figure that out as well. Here's a little sneak peek at some of the wave data. So this is, on the y-axis, we have significant wave height. So this is the measurement if you are going to go check the marine forecast, see if you want to go surfing or if it's safe to go visit the beach. This is the metric that you use. About 0.5 meter to 1 meter was roughly what this site was exhibiting in the fall. But it did creep up to 2 meters. You can see those 2 points on the graph are really spiking. You can do the next one. And then the peak wave period on the bottom is just kind of how fast these waves are, individual waves are coming in. So kind of give you a sense of how sloshy and wobbly it's going to be out at sea. But one thing I want to point out that kind of leads into our next little story is, so we saw in the forecast that a storm was going to come in. So the Reef Check team removed those buoys that were marking the different spots along the semi-permanent cable. So buoys were removed so that they didn't get swept out to sea. As you can see, there was that big spike in our data. So the forecast was right, as it often is for waves. And so good thing we took it out. And then the buoys went back in early October. And then in mid-October, one of the buoys went missing, got swept out to sea, thought maybe never to be seen until a discovery at Casper.
Yeah, so pretty interesting. This was a week and a half later, and Tristan and Morgan and I were at Casper Beach getting ready to do some surveys there. And Tristan was on the shore taking a heading, and just way off in the distance out on this rock stack, we could just see a very conspicuous orange dot. And we were thinking maybe that's the buoy. but probably not. Anyway, so we went out, finished the surveys, got back, desuited, drove up to where we could get a better vantage point on the south of Casper. We walked out on the headlands as far as we could, and we looked down there and we could see it was in fact the buoy with the big number 6 on it. And which was just crazy. I mean, it had been well over a week. I mean, it had gone all the way out to sea and just bounced its way down the coast and gotten lodged there. So there was really only one option, had to get the buoy. Couldn't let there be more plastic in the ocean, and especially not plastic with Reef Check's name all over it. So I suited up, got back in the water, got the buoy, brought it back, and that was our lucky buoy number 6, and it's still with us today.
That was the best say. Thanks, Ian. And thank you, Kristen. That was awesome. Explanation of those wave data is awesome. So in terms of other things, you know, although we didn't see any giant, like big bull kelp showing up, we did see a ton of tiny bull kelp starting to emerge very soon after we started grazing. And this was a dive Kristen and I did. I think it was like 3 weeks after we started removals, and it was amazing, like seeing these tiny, tiny baby bull kelp start to emerge. Unfortunately, like look behind this bull, I think this is the most terrifying photo, but if you look behind this baby bull kelp, there's a giant red urchin just like preying on it. So, you know, thinking about what we were talking about with those different size class urchins and leaving them, that could be very likely why we didn't see bull kelp reach a full potential. It could also be because when we started restoration, it was a little bit late in the season, and they could have likely, you saw those wave graphics, they could have likely gotten ripped out too. But nonetheless, it posed this really interesting question that I could talk about for literally years, but which is spore banking potential of bull kelp. So this kelp that we saw emerge might not have settled last year. It could be a lot older than we think it is. And so a paper, we ended up publishing a paper with these 2 researchers out of University of Alabama and University of Ireland. And I think Keenan's on this call too, but we were looking at microscopic forms, and we found these like tiny, tiny microscopic bull kelp spores in Noyo Bay in 2019, which was the year of arguably like the least amount of spores in the water. So it begged this really interesting question about how old are the kelps that we're seeing, and where did they come from, and who are their parents? So more on that, I'm sure, in the coming future. Other kind of like anecdotal fun things. The Department of Fish and Wildlife, and specifically James Ray, have been huge and instrumental in developing this project. And I had the great pleasure of getting to see James take his first plunge, ooh, red arrows, take his first plunge into the Pacific Ocean. And he helped me do some checks on bull kelp. So I just wanted to take a quick second to acknowledge all the work that he and the department have put into this project. Mike, are you here? My guest grow?
Yes, I'm
Yes.
here.
Do you want to talk about this day?
Yeah, that was a really good day. Well, so first off, to kind of build on what Tristan was saying, James unfortunately isn't here today, but he's the statewide kelp restoration coordinator for the department, and I work for the California Ocean Protection Council, which, if you haven't heard of OPC, is basically the governor's advisor on ocean policy. So we work really closely with the department on all things related to marine protection and resource management. And kelp has really been, especially kelp resilience on the North Coast, has been one of our top priorities for the last, I'd say year and a half maybe. And so I was really grateful to Tristan for taking me and my wife and some others out back in September on a dive to see the restoration site at Noyo. So this was after, I guess, after most of, September, after most of the initial pass had been completed through the restoration site. So we were really able to see the great work that commercial divers have done in getting those urchin densities down to under 2 individuals per square meter. We also saw the Downies working that day, so that was fun. We dropped right on them and got to watch them harvesting. And then sure enough, we did see some baby bull kelp on the reef. So that was really, really exciting. I think Tristan and I spent way too long geeking out over this guy right here and taking pictures and all that. So really couldn't be more excited about this project and its potential to inform our efforts. I mean, one of the biggest, James and I, what we're working on right now, our biggest project is a statewide kelp restoration and management plan. It's going to include a toolkit, various kelp restoration options that the state could deploy under different circumstances. And so, having this pilot project, understanding the lessons learned, the best practices, how we might scale it up is just incredibly valuable from a management perspective in terms of how we're going to try to bring kelp back and protect kelp that's still here. Yeah, so that was also, I'm just looking at this picture, the viz was incredible that day. I'm a Monterey diver, so I'm a softie compared to you North Coast guys, but yeah, that viz on that day in September was just incredible.
We had never, like Morgan, Ian, and I were underwater, and we're like, we've never even seen this part of the restoration site before because of how good the viz was. Thanks, Mike. And maybe you can drop your email in the chat if folks have questions.
Yeah.
Cool. Okay. Morgan.
Yeah, well, I have to say the visibility on that day was out of control good. It normally doesn't look like that, but makes it all worth it when it's nice and clear like that. So this day was super fun. We were able to secure a vessel and host our first collaboration with Bodega Marine Laboratory and Kristen Elsmore. I was Captain Morgan that day and took out a boat, and we were able to successfully pull her sensors and like the apparatus that holds her sensor out of the water. And it was essential that we had that boat because the apparatus was very large and heavy. And so I want to give a shout out to Robbie Bruce, who so kindly let us borrow the boat for the day. It was a fun day on the water.
So yeah, once again, have to give another shout out to the heroes on the shore. Susan Piercy was just phenomenal in arranging volunteers to come down and help us. And yeah, once again, just all the separate parts that went into this project, we really couldn't have done what we did with Dockside without them. So thank you to all them.
And with COVID, we didn't necessarily have a plan for Dockside monitoring in terms of like a physical facility, but the processors, specifically Brian at Zephyr, Tom at Pacific Rim, and Bob at Ocean Fresh came in so clutch with that outside workplace environment. So we really have to thank those that were there to help us offload urchin as well as dispose of urchin for compost and coordinate pickups from the community. For those of you who live locally, you may have seen these signs on Noyo Bluffs that were generously donated to us. But we put together these signs as just little infos so that when folks from in town or out of town were walking the bluffs, they could learn a little bit about our project. So if you see these, there's a little QR, what is it called? QRC, QRL? It's beyond me. Anyways, it's one of those codes that you put your phone on and then it takes you to a website. These posters are fancy like that. So feel free to go and scan it and check it out. But we're really proud of those signs. We love them. And then this last one, we've kind of talked a lot about the science today, but I just really want to acknowledge the fishing fleet for all that they have done and all the work that they've put in, not just on the water, but also the phone calls and the planning. We, as James says, are co-developers of knowledge, and it's so true. They've helped in every step of the way in thinking about feasibility and what could be done and what couldn't be done. And so this day was when there were 4 boats on the water. They finished for the day, and I could just hear Gary like, yeah, just like this like rebel scream, and it was awesome. And they just were all chanting, and it was just one of those really cool days. And so we had 6 total vessels, 2 individuals per boats. And so on the Dreamer was Rufino and Ken. On the Terminator was Robert and Jamie. Cindy Lynn were Pat and Grant. Marissa Claire was Dirk and Mike. Miss Michelle was John and Harry. And on the Safari was Byron and Gary. And so all these guys were they just killed it. So thank you. And in summary, so thank you all for spending 50 minutes. We're almost done here. All things considered, this half year, in my opinion, but I'm biased, could not have gone better. The experimental design so far is working, where we have that cable underwater. The divers are using those swim lanes to clear urchin and GPS points for the shallows. And it seems to be working to reduce urchin numbers. In total, we removed over 26,000 pounds of urchin from the restoration site. Baby kelps are present, but no survival to adulthood. Purple urchin densities were again less than that magic number we were shooting for. But when you add purple plus red urchin, and mind you, the red urchin are below the size that commercial divers can actually legally harvest, they are likely inhibiting the kelp from growing. And so Morgan's going to talk about the next steps to this project.
Next steps. Yeah, we have a very exciting upcoming season. The first thing on our list is to kind of work with the commercial divers and the state to figure out a way to handle that red urchin grazing pressure and what we're going to do about it. We are starting a second restoration site in Albion, which is very exciting. We're hoping to have that up and running this spring. And while we're starting the new restoration site, we'll simultaneously be maintaining Noyle. We'll have the divers go out and keep clearing, focus on the infiltration points. And we also will be collaborating with Mike Graham, and he is experimenting with different methods and ways to seed our restoration site with bull kelp. So exciting things to come in the future. Another thank you to everyone. It was just a huge group effort. So thank you to our intellectual contributors and funders. So OPC staff and Mike Escrow, who just spoke, California Department of Fish and Wildlife and James Ray. They've been doing amazing work behind the scenes, giving us everything that we need on the ground to make this happen. The commercial urchin divers of Fort Bragg, of course, we can't do that without their underwater knowledge and expertise. And thank you so much to the Noyo Center for Marine Science for hosting us today and caring about kelp restoration and being involved in restoration. Thank you, everyone.
Yeah, that's it. Thank you, like Morgan just said, from the fishermen to the state workers, to the reef check data collectors that have long-term data in this area. Again, the fishermen, dockside folks, landings. Seriously, everyone made this possible, and thank you everyone who showed up today to hear about this. And so with that, we will take any questions.
Great, thank you all. That was a very loaded with good information presentation, and I was especially happy to see your slide thanking the divers. They do so much work, and as all of you know, this was the third year in a row the divers have been out pulling urchin out of Noyo Bay. So it's been an ongoing effort, and they've put a lot of time into that site. So I think it's an incredible thing, and they don't get enough recognition. So good on you for that. There are a lot of questions. So I'm not sure how you want to handle this, but I can just start taking them one at a time, and you guys can decide who wants to answer them. Does that sound all right?
Sounds great.
All right, so I'll go from the bottom up since it goes back a while. So Nicholas was asking, what was the trapping method and was it beneficial? Or have you even started that yet?
We haven't even started that yet. That's like currently in the works. And step one is like figure out a prototype, obviously, like how does it actually function and does it actually work? And then the ultimate goal of those traps is to use it as a restoration tool. So that'll be coming up in the next year, so stay tuned.
Great. All right. Michelle's asking if you have data on Casper Cove, but can you tell us like what activities happen there with the wreck divers and explain that a little bit to people who aren't aware of that distinction?
Yeah, thank you. That's a great question. So everything that we talked about today were commercial diver efforts. So commercial being like, the divers that were being paid to go and remove urchin. There are also recreational efforts to cull urchin happening in the state. As everyone knows, in Mendocino County, Humboldt, Sonoma, you can now remove with your recreational fishing license 40 gallons of urchin per day. And make sure you check the regs before you go do anything. But you can remove that many urchin. But at 2 locations in the state of California, you can physically smash urchin. So like with a weapon of choice, you can go and smash urchin. And one of those sites is Tankers Reef in Monterey, but the one up here is Casper Cove. And so at that cove, divers can go and physically smash urchin. So that's looking at the recreational side of those efforts. There is long-term reef check data from both of those sites, and we have not detected necessarily much difference between those times. But mind you, this past year it was COVID, so not a lot of folks were up here diving much anyways. And so what's kind of cool about this study is that, or these 2 studies happening in the state, is that they were going to go for a year to be able to smash urchin at Casper, but now it's 3 years sunset date. So that'll be on par for both Tankers Reef in Monterey and Casper Cove in Mendocino County.
Great, thank you. All right, so maybe this is for Ian and Morgan. What percentage of the sample urchins had viable gonad? I don't know if you want to say what viable gonad is, but.
Yeah, well, most of them did. There was very few that had absolutely nothing, and it was it was kind of just dependent, and that was one of the reasons that we were kind of dissecting and seeing what they'd been eating. But yeah, it varied greatly, but there were definitely most of them had gonad in them.
Yeah, Kristen Elsmore was kind of our data gal. We collected all the data and put it in the computer, and she analyzed a lot of that. I don't know if she has anything else to say about that, or if she's even analyzed the data yet. So yeah, she's our data gal.
Yeah, I can speak a little bit to that. So I'm still doing a little bit of data cleanup because you guys keep measuring more urchins, which is great. But my goodness, you guys have so many measurements. And so I think this is also going to answer another question that was in there about kind of how that compares to some other sites. So they also collected urchins from Casper, which is another barren site. And we compared these gonads to very kelpy sites just down the coast a bit. And there's a very, very clear difference between the gonad content between kelpy healthy kelp forest sites and both the restoration site at Noyo and Casper. What I'm seeing in the cleaned processed data is there's very, very little gonad. Like Ian was saying, there is some. They're not all completely empty, but there's a very clear difference between these 2 habitat types. And then I'm curious, maybe other people have a better sense of this in terms of kind of the marketable weights, but I've heard there's a group that's called Urchinomics that is pulling purple urchins from barren sites into the lab and growing them up and fattening them up with feed. And from that work, they've said that kind of 15% gonad weight is this like kind of the target in which they can then sell those urchins. And certainly thinking about it in that way, all of the urchins from the restoration site are completely below that threshold. However, and the same for the reds that we measured, but pretty much all of the reds that were measured at the kelp control site are well above that threshold.
So just a little addendum to that on the urchinomic side. So we did a trial at Bodega with the divers and Noyo and Davis, and it took about 6 to 8 weeks, generally around 8 weeks, to get the gonad to that index that you just mentioned, Kristen. And They feed them a highly nutritious pellet made out of the offcuts of the kombu market from Japan. So theoretically, these urchin are now tasting like the most highly prized urchin from Japan. The results were all good, and they were set to take over an abalone farm in Bodega. The last I heard from folks at Urchinomics was they were having problems with neighbors, and that might be falling through. And they were having such, and they're doing this all over the world, but they were having such good results from their facility in Japan, and they were getting such a good price at market for their product. They were really going to focus some efforts this year during COVID when everything was so hard in Japan. So hopefully we can get that started again. And I think really making a market for those purples in whatever way we can is a huge piece of this problem. All right, so the next question, are reds larger and more detrimental to kelp recruitment than purples, and will you remove reds next year?
Yeah, that's a great question. So to the first part of that, red urchin can get larger than purple urchin, but arguably they can be the same size as they're growing to a certain size, as we saw from those size distributions. As for being more detrimental to kelp, I can't really say definitively, but I can say behaviorally they function different. So purple urchin, I think of like the red urchin as this like more effective, like fast urchin as opposed to a purple urchin, but that could just be, that's just my observation underwater sometimes. So they both have the ability when they're hungry to just like clean house. So in this circumstance, because of like, there being a fishery up here and the fishermen who we're working with really want to make sure that if we were removing red urchin, that it was really like vested in science. And so that's why we took the time that we did today to kind of walk through why we got to the point that we did in terms of removal of red urchin. And our suggestion from the science perspective and what we're seeing is, yes, if we want to see kelp grow, we do need to reduce red urchin far below what they currently are at. And mind you, again, all the red urchin that are currently on site are not harvestable because of their size. So that would take a separate process that's being explored right now. And if you have more questions about like the process for that, Morgan, maybe you could jump in and answer those questions.
Morgan just got admitted. She must have
oh, bummer.
She got kicked off.
Oh no,
yeah, I just got back though, so if you want to re-ask the question.
Oh, the question was just, are we removing reds? The answer is yes.
Oh, okay.
And I can add a little bit to that about kind of, is one species more detrimental than the other? And there are a couple studies that I'm aware of that are in the works that are actually trying to explore that. One down in Southern California with a group down at UC Santa Barbara, and then another, but that's more focused on Macrocystis, the giant kelp, which is in the picture behind me. And then another group up at Bodega Marine Lab is exploring this kind of looking at Macrocystis and Myriocystis and some other species. So hopefully those numbers will help kind of inform these decisions as well.
Okay, next question. Oh, sorry. Wow, that's bad. What explains the ratio of purples to reds?
Human interaction. We are a predator in the system. And so, we've, not to get too deep in all of this right now, but we have been manipulating the system for a while, right? And so anything that you see as a response underwater is an artifact of us and our interaction with the ocean. And so as for this particular circumstance, the ratio of purple of reds a while back, like when this first started, there was a purple urchin recruitment around the time that we lost sea stars in 2013. And I know most of the folks on this call didn't need to hear the whole perfect storm bit because they're very familiar with it. But, we had at the same time, like elevated water temperatures, loss of sunflower stars, purple urchin recruitment. And then purple urchins, disproportionately affected abalone and red urchin. And so that, obviously caused that difference in ratio between purples and reds. But what we're seeing on the site right now at the restoration, like that again is human induced. So we're manipulating the system so that it does look like that. And that's why you're seeing like those differences in ratios. Did that answer the question?
Robert will have to tell us. So Robert is asking, why did you decide not to replicate the removal and control treatments? Was it the level of effort required? Pseudo replication would have been taken into account in interpretation.
Yeah, so in terms of replication, that Morgan had mentioned, the second restoration site we're going to is Albion. So that's another site where we're going to basically parallel the same methods and try that at a different site. I know there are a lot of Monterey divers on this call, or, Southern California, just divers, right? One site is so different from the next. And in Northern California, they're like these little microclimates, like each cove that you go to is so different from the next. And so finding an adequate comparison is really difficult. It's really difficult to find something that does look so similar that you could say, these look the same at this point. And so that makes it really difficult to have replicates. And so we didn't necessarily have replicates within site. Also, because of the way that our reef is structured. In Central Coast, Reef Check and Keith that I think was on here, have been leading this project at Lovers on these, like basically manipulating the density of urchin on each of these patch reefs. We don't have patch reefs up here. We have one long continuous reef. So our ability to replicate is a function of what we have up here, which is a large continuous reef. So that obviously played into our study design, and that's why it's been so challenging to do work up here also, is just the study design in general. And sorry, last thing, the sand inundation at the sites up here, they, like the way the sand comes in and out with like the river outputs and everything too. Some of these reefs will get buried one year. Like I was at McCarricker and it was like 15 feet of water. The next year I went back and it was like 25. So you can get these like sand inundation moments where it buries these patch reefs also.
Fascinating. All right, I think you kind of covered this, but I'm going to ask it anyway. To what degree does the size of the test affect the degree of pressure on the ecosystem? There used to be a large number of 1 to 2 centimeter urchins that had limited impact on the kelp.
Tristan.
Yeah, I sort of touched on this, but I guess the real hard numbers on that are TBD. With those studies that are looking at the feeding efficiency and kind of how fast. There's definitely been work on this, but not necessarily in the context of Nereocystis or really looking at the reds, because I think, please correct me if I'm wrong, but generally speaking, I think really it's been perceived as the purples have been these like problematic barren forming urchins, whereas the reds don't really do that behaviorally down in Southern California, where there's been previously a lot of issues with urchin barrens. And so I think this is kind of all new territory to some extent, at least in the North Coast, for red urchin barren behavior. And so this is still being actively explored, and hopefully we'll have some results for you soon. But keep an eye out for that with the group down at UC Santa Barbara, as well as Bodega Bay. That's where those results will come out.
There's a nice group of research projects being done right now, so there's a lot more coming. Okay, Michelle wants to know if you can say anything about abalone or sunflower sea stars from your surveys.
Yes, abalone. Actually, Ian, do you want to take this one?
Sure. I mean, start with the big one. I mean, sunflower stars, we have not seen any at all, and no sign of any at all. So that's a little bit of a bummer, but they are on that red list now, like Tristan mentioned in the beginning of our presentation. So Hopefully there'll be a lot more light will be shed onto them and some funding to kind of research them and outplanting. But want to touch on abalone?
Yeah, just on the abalone, I mean, just from the surveys that we've done, we see patches where there are some and areas where there are none. And it's really, I can't definitively say either way if they're making a comeback, but we notice there are areas where the densities are decent and other areas where they're not so many. And it is variable from year to year.
Yeah, and it also seems like they kind of get pushed into these areas. And so it makes it seem like the density is high in that area because they've just been pushed to this one little rock, but overall their densities are quite low.
Can any of you talk about Pycnopodia captive breeding research and who's doing that and where we are? Is anybody having success?
Yeah, I can speak to that. So that's one of the projects that the Nature Conservancy is spearheading with Jason Hoden at University Washington Friday Harbor up north in Puget Sound. There were some, as sea star wasting just like wreaked havoc over the Eastern Pacific, there were some remnant populations of Pycnopodia left. And so they were able to grab a couple of them, and they have been successful in rearing them and getting them to spawn, which is like super, super exciting. And so the question now is like, what is the best way to actually get them to breed and outplant? Lana Cohen, I don't know if she's on here, but Mendo Voice will be, I think, doing an article on this in a little bit. But yeah, it's super exciting that they've actually been able to rear the Pycnopodia. And so at this point, the question is, like, can you do it? Can you get enough of them? And if so, can you outplant them? And is that like ethical? Is that something that we want to do? So that's kind of in the mix right now, but exciting nonetheless that folks are actually making some headway with that. It's been a long time coming.
Yeah, it really has.
Yeah.
Well, there's been a spirited discussion in the dialogue about take of purple urchin. So I might have missed a question in there. So I want to offer now for people to unmute themselves and ask a question directly if you'd like, if we have missed your question. It's been a super active chat.
Tristan, I got a question.
Hi, Chris.
Years ago, I did this, LA Waterkeepers did this with the Santa Monica Bay Foundation, Brian Mew, and all the rest of the people. So we did all this, and finally Fish and Wildlife gave us a permit off of PV, and we got to go do this. They gave us a permit that had allowed us to use a hammer to go underwater and smash them. And of course, we saw the kelp grow back and all that. So my question is, now you've gone back to the removing versus the smashing. Because it was so much easier to smash. I'll tell you what, it was easy to go out and smash them out there. So what has changed with Fish and Wildlife that they're requiring you to do that, take them off versus smashing them?
Yeah, great question. So for the state, I'll just speak to, because smashing is allowed in those two recreational places, right? Casper and Tanker's Reef. But for this particular project, remember all that landings data we were able to show with the gonads and the sizes and what they were eating and what they weighed and what their gonads weighed and their jaws, all that stuff. And thinking about like the poundage landed, we wouldn't have any of that information if we were smashing underwater. So our ability to just answer some of those key questions of like, how much are the fishermen landing at each of those cells? How many at the GPS points? Like that was only done because we were like, fishermen were physically harvesting urchin out. The other reason is the commercial divers, they are fast. Like, let me tell you, like those, if you see them working underwater, they are so effective. They have like their system down. Some use rakes, some use claws, some use bare hands. And so they all have their method of doing it. But when you smash, there's a really, like at the speed that they're going, it actually takes them longer. If they're smashing and having to go back and like, did I kill it? Did I like miss it? Do I need to go back? When you remove, like, think about it as like throwing tortilla chips on the ground. And then you're like stepping on a bunch of them and then you don't vacuum, versus like if you just like smash them and then vacuum. That's kind of like the difference between like leaving the urchin underwater, at least visually for the divers, versus just taking them and putting them in a bag. I don't know if that was a great example, but I think you can get like the visual component there.
Looks like Michelle has her hand up. Michelle, you have another question?
Yeah, I do. Tristan and Ian and Morgan, since you can't get to the 2 per meter square with the combination of the purple and the reds, couldn't you just remove additional purple so that you got there so that there was still some red and less purple? I mean, couldn't you?
Yeah, that's a great question. And we tried as hard as we could. Like that's the rub, right? Which is we did everything. We did passes through it multiple times to get it down as low as we could, and we did. But someone asked a really good question about like the effectiveness of red urchins too. And they behaviorally do different things. And so what we saw with red urchin is when we talk about densities, we're talking about a whole site, but in reality, what could happen and what does happen is they'll be stuck on one place. And so what happened is like you're clearing out purple urchin across the whole site, and you're creating space for red urchin to come and start feeding that kelp line, right? And so behaviorally, they're in spots where we just like really don't want them to be, because that's like the most vulnerable kelp patches. And so we like that's why I think it's so interesting, because all of them are like below that harvestable size. And we've explored every option we can to not remove reds, but we're at the point where like, if we want to see kelp, we got to do it. Morgan, Ann, do you want to add anything to that?
Yeah, I mean, even that picture you showed, with the little baby bull kelps, and right behind it was this big red urchin, ready and hungry. So yeah, we have seen the red urchins move across the reef. So it's a different kind of behavior once we move the purples. And yeah, like Tristan said, they're just gonna seek out any kelp that starts to grow. They're gonna seek it out.
Okay, and then I have a follow-up question regarding funding. Are you set for funding for next year, or is that something that is before the state? Have we heard? When are we going to hear? What are we doing with the funding?
Mike still here? Morgan, do you want to speak to that? Reef Check is in the process right now of getting another year of funding for this effort, predominantly because COVID delayed the project for most of the springtime, but also getting to Albion. And you have to think like year one was to say like, could it be done in terms of like wrangling like all these different pieces. And so it's kind of like demonstrating that effort. And so now we just need to communicate it and see if the state wants to continue, because we all know after a fire, it takes a few years to see everything grow on top of that, right? And so we're not necessarily expecting in 1 year to see bull kelp growing all over the place, but there's a really good chance that if we do this project another year, it will. And then the other reason why the state may continue funding for another year is because there are a bunch of sea grant projects, like the one Morgan was saying with outplanting kelp, that want to do it at the restoration site. So we need to maintain the site. Reef Check needs to maintain the site so that they can do those extra projects there. Morg, do you want to add anything?
You pretty much hit all the details on that one.
Do we know when you're going to know for sure that you've gotten the funding from the state? And what about federal funding? Is there any federal funding in the works?
Hopefully we'll know soon, very soon. I'm not quite sure about federal funding. Tristan, you might know more about that.
Yeah, we applied for federal funding like last year, right after we received these funds. We applied with the Greater Farallones and a few others, and that was not accepted. And so maybe in another year, it's always a constant flow, and especially with kelp restoration and just kelp in general, it's just taking off. So I'm sure there'll be opportunities in the future for the project.
Okay, we're getting close to an hour and a half here, so I'm gonna let Dylan be our last question. He has his hand up and he's been very patient.
That was an awesome talk. Everybody hit a home run with it. That was so cool. I had my question is kind of two-pronged. The first part of it is basically, since you talked about that there was very little macroalgal abundance, I was curious if you thought that the urchins might be then consuming something else and like they're switching what they're eating, or if they were just literally starving.
Yeah, they literally ate rocks. Like some of them, I think that's what was so cool about like splitting them open and looking. We spent a lot of time like looking at their stomach contents, but a lot of them ate straight rocks, and others were eating fleshy red algae, and then others were eating green algae, and then some, once fall came and there was like floating dead algae, they would eat that. So it was really cool. Maybe Ian, you could jump in and answer that.
Yeah, no, I mean, there wasn't anything that an urchin wouldn't eat. I mean, we were finding, I mean, articulate coralline in there. I mean, bits of crab shell. Jellyfish. We've seen them out there a couple times, like munching on live snails. Yeah, anyway, it was just, there really was no limit to it. I mean, it didn't matter if it was alive or not living. If they could get to it, they would take a bite out of it for sure.
That's crazy. And then sort of on that same note, I was curious how commercially viable the red urchins are in this low gonad index state. Like, is there a cost benefit where it just might not be worth it to fish them in areas that don't have access to macroalgae?
Is Grant on here?
Yeah,
Grant, are
Grant,
you here?
Grant, why don't you unmute yourself? Let me see, I can ask him. Oh, there he is. You still have to unmute, Grant.
Sorry, kids are here.
It's okay, we like kids.
Actually, the commercial market for any urchin right now is very high. Statewide, our harvest is down. So the domestic market is pretty hungry for anything you can get, if it has gonads at all. Marketable urchin is probably about a 4% is a low for the gonad index inside.
Awesome.
You and your dad were the last two divers diving locally for commercial reds, right?
That and then Dreamer, Rufino's still diving. So it's pretty bad. There's some other guys we've got some guys trying to go down in Point Arena now. There's a lot more kelp down that way.
So Gary was flying all the way up to Alaska to get reds and bring them back down here, and it was still profitable to do it that way because the market's so strong.
So
Yeah,
great.
I mean,
Sorry, you said 4%, as in this
yeah,
many.
a 4% gonad index can be marketed. So that's that's
wow.
depending on the color and the structure would define its grade, but that's your low end, that's your low quality urchin that you could harvest.
I mean, obviously, from harvesting in and around Noyo, but looking at the data that Reef Check and the volunteers collected, almost all of the urchins, even in the restoration site, are above that 4%. So that's pretty crazy.
And you were saying, Grant, too, that you have to go a lot deeper now to get your reds, right? So it's a lot more dangerous. That's the other problem.
Yeah, the urchins that we're getting locally are coming off of a deeper shelf, that 70 foot and deeper. They're eating barnacle blooms, so they're really small barnacles that are growing all over the reefs like a fuzz. It's a really firm uni, but the color and the taste isn't as good as your good kelp urchin. There are some good marketable urchins really in shallow in the tide pools. Like the presentation said, the urchins are looking for food just like everything else. So the reds are competing to try and get something to eat to keep them healthy. they're a larger organism, so they can't go as long as the purples can without dying off.
Did you get any purples commercially this year?
Yeah, we harvested probably about 4,000 pounds of purples this year.
So they have their spots where the purples are bigger that they can go get for commercial harvest as well.
Yeah, the purple urchin actually has a sweeter taste than the red as well.
All right, I'm going to call it here, people. This was an excellent presentation. Thank you so much to everybody who contributed. Yes, that was most excellent. Somebody asked a question I see right now about wreck divers. So our wreck diver partners are the Watermen's Alliance. So go to the Watermen's Alliance Facebook page and you can find out more information on the wreck diver situation. There's some information on our website on Noyo Center if you want to find contact information. Noyo Center has the Discovery Center in downtown Fort Bragg, which has been closed this entire year due to COVID, sadly. But when we open up, we hope to have a new kelp forest exhibit that can help teach our community more about these issues. So keep your eyes out for that. And we will, I mean, with the response to this talk, we clearly need to have more of these talks. So we will try to pepper in more kelp related conversations in the coming months. So keep an eye out for that. We do have a very busy March. It's March here in Fort Bragg is Whale Festival season. Again, the Whale Festival is largely on hold because of COVID, but the Noyo Center has a whole host of events, virtual and mostly, including 3 really great science talks. So go to our website and find out more information on those talks. And of course, our scavenger hunt. This is one of the fun things that we're doing to get people out safely on the coast and learn more marine science about their coast. So join our scavenger hunt. All that information is on our website. And we hope to see all of you again sometime soon at another talk. Thanks so much and have a good evening, everybody.
Thanks for having us, Sheila.
Yeah,
Thank you,
thank you.
Sheila.
Great to see everybody again. It's lovely to see your faces.
Thank you.